Hello everyone, it's me again, it's Heider, and today we're going to talk about something, I wouldn't say new, it's about a few years old, but you probably might have seen my videos on the OMAP and how I build things on the OMAP, and currently in progress, doing lots of stuff at the moment, but I decided because I have a requirement to do something on video processing. Even though the OMAP is a 450 megahertz chip, the DSP is 300 and it's a single core. Um, the This one, however, the one I'm going to talk about today is the ESP32 S3. This is a dual core chip, 300 megahertz processor, and it does offer a lot more than the OMAP. It's got Wi-Fi and Bluetooth built in, as you can see. But the main thing is I wanted to talk about this because I'm using this to develop something, and this video is going to be mostly a reference for me, well, to help you to set up your environment, how to debug things on this one, which is really important for JTAG debugging and stuff. And not many people talked about it on YouTube or the internet. So I'm going to discuss this, how you set this up on CLion, CLion or CLion, I call it CLion, to get this whole thing to debug, and you can put breakpoints and stop things, and take things further. So I think the target we're going to reach today is how to put a breakpoint and stop it to work with this as we go along. Anyway, the first things first, where you get the board from. I got this one from mouser.com, or I call it UK in here. And Mouser sell these, and they're very, very good. And this one I have, just wanted to show you this here. This is the Dev-Kit 1.0 Obviously, there's flavors of it, so you can get Dev-Kit / numbers, and these numbers could be PSRAM and flash and all that kind of stuff. But Dev-Kit 1.0 is fine. It comes with two USB-C ports, so you can see that there. This one, by the way, I put a little adapter, a little extension. Just going to take that off now. I beg your pardon. So two micro USBs. It's not USB-Cs. Sorry, I got these wrong. So yeah, two micro USBs, just in case. Yeah, so I put this in here into the USB-C. And the reason I do that, because I have a cable that I use for, for USB detachable cable. It's really magnets, really nice, makes my life easier. So I can just do this and the whole thing works fine, right? And if I take it off, it's done. I'm out. And I can plug this also to my iPhone. Got another for this one, for example, an iPhone extension. So this one is, and they're very, very useful. I love these. Make my life so easier. Anyway, so the thing comes with two ports, as you can see here. One is a serial only, which you can debug things for using the serial interface, and this is what you install with Arduino, stuff like that, and you can output things. That will also output Arduino as well. But this one here, which is the opposite, so where the light is, not where the port, so not let's say on the red light side, call it this way, so you know exactly where the port is. This is what we're going to use for JTAG debugging. So why I like this, the ESP32 is actually this big. That's the ESP32 chips, only that. But the rest of the board is to help doing JTAG and debugging this. So I can put a breakpoint in the middle on the board, stop it there, and then do the stuff to find out what what necessary things to do. So the hardware now is sorted out. We're going to talk about where to get things from. So let's just take you to the smaller screen, or to my screen capture. And you can see here, I'll put all the links in the description. So I'll put a link to the card itself, where to buy it from Mouser. And I'll also put the description I'm talking about. So this one here, for example, we're not using Arduino today. Arduino is, this works Arduino absolutely fine, but today we're going to talk about native developing on ESP32, which is using the ESP32 IDF. And ESP32 IDF is a framework, beautiful, loads of things in there, and it's a massive thing. It's a huge beast inside. We're going to develop, so anyway, let's just carry on with this one. So installation wise, this link talks about how to install. So you got for Linux users, you do stuff for Mac OS users, which I'm actually doing today. So we're going to talk about Mac OS only. We're not going to talk about other operating systems. And I'm using an Apple M3 chip, which is the Apple Silicon. My hardware setup is this laptop is 2 terabyte, 64 gigabyte memory. And yeah, so basically it's a super duper latest machine, and we're going to use that to do this demo. So for Mac OS user, you use brew to install, so to install CMake, Ninja, and DFU util. That is a pre-requirement you need to do. So you need to look online if you don't know how to do brew or what brew is. Find out what brew is and then install this way. So this will install the pre-requirement. And then, once you're done, you need to download you need to install what's it called? I would call it the Xcode tools, software update. So basically, I would have Xcode installed from Apple if you can. It just saves so much time. We're not going to use Xcode in this example or come near Xcode, but Xcode will have the command line tools as well, which the other stuff uses, etc., etc. So make sure also Python is installed here. If you haven't got it installed, you can just do a brew install Python 3. But usually, if you're running the latest OS now, so if I just go on about the Mac, this one. Basically, if you are running, where's the OS? Yeah, if you're running the, Sequoia or Sequoia, Sequoia. Anyway, Sequoia OS 15.0.1 as of the video today. Then you should be having Python 3 already installed, because I ran this as a Virgin machine. It came with Python 3 installed already anyway. So now, going into the ESP IDF, you create a directory. I know I'm actually talking about manuals, but at the moment, because I already installed the product, I'm just going to take you through how to what you need to do. I don't mind actually. Let's just do the installation as we go along, if you like, just to save you time and how to do this. So if I go into a let's just go into a temp directory, for example. So mkdir, let's just call it YouTube IDF for the argument's sake, okay? And I'm just going to cd to this one. And now, so I created the directory, and what you need to do, you just need to clone that from GitHub, which is this GitHub ESP the ESP IDF. If I do this and I press enter, it'll create another directory for me, which is ESP IDF inside, and I don't want that, so I'm just going to do a dot at the end to do it inside this YouTube IDF folder, and no more folder inside this. So I'm just going to do that now. So now it's downloading the stuff. It shouldn't take long. If it does take, I'll speed up the video, but we're 20% already, so should be okay. Nearly there. Yeah, the recursive option downloads the rest of the stuff that's required with it, which is very useful. If you don't specify this recursive, you'll be just downloading the API, the language itself, or the framework itself, without the other, sub-components, call it. So now we're downloading this. And I'm probably going to speed up the video in that case, maybe. Good. So that took about roughly, I would say 5 minutes, give or take. So now we have everything done. So if I look into here, everything is exactly where I wanted it to be. So inside the YouTube IDF, we got this one. So now what we need to do, just going back to the document. So now this is done. Step 3, the installation. And here we have install.sh ESP32. So obviously, as you can see, yeah. So we'll do that and install.sh ESP32. Yeah. Actually, I'm gonna stop this there. Hold on. So ESP32, I'm gonna do all instead. Just do the whole thing. Installing all the boards. It makes sense. The reason I do all because I would use the current setup here is referring to the ESP32, but we're using ESP32 S3 of Dev-Kit-C as well. So all makes more sense in here to install the whole thing. Yeah, so probably another speed up to the screen. Yeah, no, there you go. So now we got it all installed and everything is exactly how we wanted it to be. The other bit is we need to do, just gonna confirm, so that's all done. You can do, part of the video, part of the stuff, but all is absolutely fine. That's what I did. And then what you need to do is run the export. So in here, /export.sh. That creates the shell command. So basically when you do that, you're actually allowing the shell to create stuff. So when I do idf.py, it actually comes up now. So now we have this ESP thing installed. So that's all done. The next phase is to install or to get your example project set up. So we're going to go to examples and then get started. I'm just going to go to the document, just make sure that we haven't forgot anything. The alias, I don't really like doing aliases on the OS, so I'm gonna skip that part. Alias get IDF whatever. I'm not gonna do that. And steps on the ESP IDF, blah blah blah. You can continue reading if you like. Yeah, so this is idf.py is like a shell. It's like make. In other words, if you're using Linux, if you're using Linux on bare metal and stuff like that, or debugging or hacking, idf.py is like running the make. So when you do make menu config, you do an idf.py menu config, and then that's how you set up the environment and tweak things up. And I'll explain that now. So if I go into, for example, and we go into link, and now we have the project target, but don't do anything yet until you set up the target. So what we need to do in here, we're going to do an idf.py, and then we do set target, and then we do ESP32 S3, because that's what your chip is. And if you don't do that, you'll have lots of problems, lots of errors, if that thing will work anyway. So now we have configured the thingy. Just to let you know also, you run that command when you're inside your development project, not inside anything else. So that's done. And if I do idf.py and then menu config, if you like, this will if you use the Linux and building up Linux, you'll understand what that means. But just to be on the safe side, so things like serial port, things like enable Bluetooth, enable stuff, enable TLS, enable web server, that sort of thing. All the stuff that you need to run on the chip in order for it to work the way you like. So there's tons of stuff to be here. Refer to the documentation for more information, but this is it's basically the chip. So I think, to be honest with you, a lot of that stuff you'll see on Arduino as well. So if you are used to Arduino, for example, the flash type, the SPI, the QIO, that sort of thing, these will be available on Arduino. So you can see them in Arduino if you like. And that's, if you have done this on Arduino before, you should know what that does. So anyway, we're gonna exit without doing anything to it. And now we set up the environment, everything looks good. The next phase is to go into the what's it called, the CLion or CLion. Now we're going to do is look into the CLion or CLion. This is the IDF. Sorry, this is the C development environment that I paid for. You can use, I think you can use it for free as well, but I choose to pay, just a kind of a royalty appreciation for what they did. So it's a really good system. So now I'm going to start this up, and I'm going to open a new project, or open a project. We installed the system under YouTube IDF, and we did, sorry, before I open the project, things we need to do. Very important. So settings, go to CLion settings in here, and access the tool chain. So build, and then tool chains in there. Add a system one, and just call this YouTube ESP32, just in case, and then add environment in there from file, and then we pick up the one export.sh, that one we just did here. We just installed. You can see the directory there, and that should be okay. Apply, and then okay. That's literally what you need to do to set up things on the IDF. So we're going to open a project, and we're going to the YouTube IDF examples, get started, the one we just configured, the blink, and then open that up. So now we have a dialog in here. You can take this if you like, reload the project after whenever you change cmake.list. That's absolutely fine. Is really preference. By default is actually off. I'm gonna take it just in case. So the name is the debug, and the tool chain we're going to use is the one we just configured. So this one is the one tool chain we're actually using now. Generator, default Ninja. We can do Ninja, or let CMake decide. Let's do this one. Just let's say CMake decide anyway at the end, and then okay. So now we know the project is now going to use our new tool chain which we set up. So in here, I just need to go, just gonna put it full screen, and then take that there. And this time I'm going to do a build project, and let's see what comes up. Cannot find CMake project profile, and it should find it. I think it's just loading up now in here. Maybe I'm being too quick. Yes, loading CMake project, as you can see down there. So that looks good. It's doing some caching up, which is nice. So I'll just wait for that to finish. Nearly there. Very good. Now, tools, CMake, and then reset cache, and then reload CMake project. That's it. I tend to do this step even though it's not necessary, but it's good just to be on the safe side. So now we can do a build project, hopefully. There we go. So it is building up. So everything looks good. Okay. So I think, yeah, so processing stuff. So pretty much because you're starting this for the first time, you'll be greeted with this kind of stuff, which is okay. Right, so now that looks all good. Build target blink.elf, so that's still in the ELF file. Refreshing files. Yeah. Okay, so what we need to do is the target. So if you look at this in here, the target I would like to do, yeah, there we go. And I'd like to set it to flash. Flash means send it straight to the chip, to the development board. So I'm going to run this now. And executable should be blink.elf, which is that. Argument, we have nothing to set up really, so apply and then run. So we'll just wait for that. And now it's going to flash and upload. So you can see that here. It's doing the flashing. And it should come up. Is it up? Yes, you can see that blinking now. So the light is blinking, which is great. And that's stage one. This is the first bit that we needed to do. So now we have a successful installation working on the system. Now, the second part is to debug that. So if I wanted to, for example, get into the code, so inside examples, get started, blink, and then main, and then this here. And if I say, for example, I wanted to put a breakpoint on line 97, so which is the while loop, or maybe the configure LEDs. Yeah, configure LEDs is fine, just at least we'll stop before. So if I click the debug icon in here, and we're waiting for that. Yeah, see that? You'll get this error message, and a lot of people haven't got a clue why they cannot debug, and you know, loads of things. Well, this means nothing. It just means LLDB doesn't understand the code and how to debug it there. And the documentations, when you try to follow them, they are not really useful in a way to explain how this whole thing works. So anyway, we've done with this thing. I'm just going to move it there. And now we're going to learn more about the OpenOCD in a second. But I just wanted to highlight one thing. So GDB does not exist on MacBook M1 or the M3 version. And if you have Windows, you probably have GDB set up, so you can say GDB debug, blah blah blah. But and also if you have a MacBook Intel, it will work probably fine. But because this is an Apple Silicon, GDB will not work. The alternative people might think using, and this is why I actually came across, is LLDB. But LLDB is not meant for debugging that stuff. Thankfully, ESP32 or Espressif did a bundle and an ESP GDB version with this that we're going to use now to debug the stuff. And this is how you should be doing your debugging session. So let's go back into this one now. And we're just going to click the edit. Sorry, before we do that, we need to tell how to debug the stuff. First of all, you need something called the OpenOCD on-chip. OCD means on-chip debugger. This basically means you're going to be using the stuff over here to talk JTAG into this ESP32 to debug it at some point. So OpenOCD is essential, and don't worry about where you're going to get OCD from, blah blah blah. If you go into a normal shell like here, yeah, it's not there. Command not found, and people are kind of scratching their heads, or might be scratching their heads. What's going on? Where I'm going to download it from? Blah blah blah. Don't waste your time. Don't go and download it and install it, because when you run the export in here, so when you do ./export on the shell, which we did earlier, that creates an OpenOCD for us as well, and you can see that there. So when you run this OpenOCD, you'll get stuff out, Don't worry about what that says. Just at least we know we have OpenOCD. So what we do is which OpenOCD, and that tells us the OpenOCD binary that we need. So just copy that here. So when you do which OpenOCD, i.e. where is it running from? So this is where it's running from. You take that down, go back into CLion, and into embedded development, and then paste it in here. So paste and then test. Once you test it, then that is a good sign. That means you should be able to run OpenOCD on chip debugger there. We're not done yet. This is not the final phase. The other bit is we need to set up a debug environment, a debug profile. So we're going to do that now. So edit, and I'm going to click on the new environment in here, and OCD, yeah, that one, OpenOCD download and run, this one. So I'm going to call this here ESP32 YouTube, just YouTube ESP32, right? And I'm just keeping everything as a default. Basically, if I do a blink.elf file in here, where is it gone? A blink, here we are. Blink.elf, that's the file. I'm actually going to take you through the documentation now. And I'm going to show you where the gotchas and where things are going to go wrong in this documentation. So OpenOCD support, you need to do that now. Look into the documentation, all platforms, and we are looking for yeah, OpenOCD, blah blah blah. We've set up the OCD, we've set up the tool chain. That's all done now in the video. And create OpenOCD configuration. Yeah, so that's exactly what we're doing now. So OpenOCD, and you can see you put the ELF file on this first and the second window, right? So in here, blink.elf, and then in here, bundle GDB, which is that one, and then the boot config file. And this is the other bit that people are not really getting right. And let me walk you through this and explain what that means. So on the expressive documentation, how you set up your debugger, and what it says you're using the chip in here, which is Dev-Kit-C. For some reason, the documentation says use ESP32-W-Rover-Kit CFG. Okay, that's not the right board. This is incorrect. For that, you need the built-in tool to use, not this one. And I'll walk you through this and explain what's happened if I do that. So if I take the board file there and then paste it into here, okay, as the documentation says, and apply, and then click debug, here's what's going to happen. Right, and you got this error. So you got user blah blah blah, error 9, ELF file, you know, it's just not going to work. And go back into your config, edit, and click the assist button. Change that then to the ESP, what's it currently now? The board ESP32 is what we need. And it's going to be the built-in ESP32. Yeah. So you've got lots of files. You got the bridge. Bridge file is used if you have an external JTAG connected to this. So if you have a similar device to this, not this itself, and you have something like that, for example, you know, a little different device, and you connect it through another ESP32, another debugger that connects to this one, that's called a bridge. We're not setting up now. Because that whole thing is, you know, has got all embedded, and we're going to use, in this case, the built-in file. So, but we're not using C3, we're using S3. So ESP32 S3 built-in, that one. That's the right file. So use that one for now. And OK, apply. And the other gotcha is if I run this again one more time, there's going to be another error. So now it's loading up stuff, and it's going to go into loop, or, you know, trying to load the things up, and you know, it's just not a happy ending. So there we go. That's the other bit. And a lot of people, including myself, I was actually scratching my head for, a couple of days. And so what the hell's going on? Remote G packet replies too long, expected, blah, blah, blah. And a lot of people will have that error. And I went on a wild goose chase trying to find out exactly what to do, what GDB, recompile stuff, loads of things. Eventually, after I created a ticket with the Espressive, I'll probably put the link on the description somewhere, they came back with the command. So we're not really using GDB in here. We're using the built-in GDB tool that's meant for this one. So if I go into this one again, so click on the debug, edit. We're not using the bundle GDB, so we're going to do custom GDB executable in this case, and we are literally looking at this, and it should be under YouTube IDF and I think tools. No, let's just get the right one done, and it should be, I think it was ESP. Let's just get this there. So, as I said, luckily, Espressive has provided a documentation on where to download how to use the GDB debugger. So now we're looking into this one. The right tool is called Extensor ESP32 ELF GDB. And you can see when you run it, it comes up with nicely here. So copy that and then paste it into here. Apply. You can actually say, if you like, which, that, and that will come up here. So you can just copy the whole thing, paste it in here, and then OK. So now if you run this again, debug, and debug now, sorry, edit, why? Yeah, that one. Yeah, ELF GDB, that one, open, and apply. So debug, there we go, yes. So now we'll see a different error this time. Debugger connected to localhost, and you can see that now is actually, it stopped it. So you got the light is now broken in the middle, and it's waiting for us to do something, but the debugger is still connected, but it's, error invalid instruction, memory -4, which is another error completely different. And that is not documented at all anywhere. So what we need to do is go back into, so stop it, go to debugging mode. I clicked debug again, sorry. Stop it. And I'm going to get into this one, edit the configuration again. You see the target and the executable binary. They're both set to the ELF file. And I'll take you that now here. I'll explain what's going on. So if I take you into the debugging session of how this whole thing is, is telling you to do it, that we've done. We don't need that now. And where is it? Yeah, so you see that here. It's taking you 1, 2, 3, 4. So these are all incorrect setup. So we fixed the GDB, we fixed the other stuff. The targets in here are not, this is incorrect setting. So what you need to do is your target, you should be doing do an app flash in here, and you set the target in here, that's correct. And the download, if updated, so apply and then debug. And let's see now what's going to happen. So there we go. So now that's flashing up. There we go. Now you can see it. We got a breakpoint set up. So is a happy ending, I think, so far. So we got the thingy here up and running. Perfect. And now we set, it's actually waiting for us now. So if I just do a F8 so go here, F8, to debug. So now the pin is, or the LED is off. F8 again, F8, blink, F8, and then try one more time. And then blink, it should be on now. There. So you can see now, I'm actually doing it in slow motion. And that's how we do it. So hopefully that is, that's how you set up your environment to debug stuff. And many people found a lot of problems with how to set this up. Documentation doesn't really say the right stuff sometimes, but my video hopefully should help you to set up your ESP32 environment, and this is how you debug the chip. And the device you can get from Mouser. So this document, by the way, is not only to help you out, but also to help me out one day, in case I forget what I did. So it's a good reference for me to get back to things and then take it from there. So I hope this video explained how to debug with ESP32 on using CLion or CLion. Thank you for watching, and have a lovely day. We'll see you later.